All right, here's 1.3. This is the video notes. Make sure you follow along as best as you can. Pause the video if you need anything, if you need to write anything down. Okay. What we are going to be doing is called the properties of mathematics currently. These are basically things that you normally do in math that you just know. We're actually giving them words and terms that you can follow along with and understand. Okay. Let me shoot an autofocus right here. I just don't know if that looks very good. See if that looks a little bit better. I think that looks nicer. Okay, so what we're looking for here is the commutative we're going to start off by just starting at the commutative property of addition. Okay, the first thing you got to understand is what it means is you can move things around and get the same answer. Okay, and they use math words which say a plus b equals b plus a. I am going to use I'm going to use an example using numbers. 1 plus 2 is going to be equal to 3, correct? Which is the same thing as saying 2 plus 1. Okay? You can move things around and get the same answer. So if I switch the places of 1 and 2, I'm still going to be the same. It doesn't change it. Okay? And just as the commutative property of addition says you can move things around and nothing changes, you can do the same thing for multiplication. So you can move, again, things around and get the same answer. A times B equals B times A. Dot is not showing up there. That's weird. Okay. I think the lighting. A little bit better. Okay. So we can move things around and get the same answer. So for A times B equals B times A. Once again, you can look at it as something like 2 times 3 is the same thing as 3 times 2. Okay? Really looks out of focus. I don't know why. So, next one is the associative property of addition. You can group things differently and get the same answer. So what they basically say is that we have 3 letters here, A, B, and C, and if I group B and C together, it's the same thing as if I grouped A and B together. Okay? So here's how I want you guys to think about it. Let's say A is 1, B is 2, and C is 3. Well, 2 plus 3 is 5, plus 1 is 6. And then if I do the same thing here, but this time we group the 1 and the 2, we'll ungroup the 3. 1 plus 2 is 3, plus 3 is 6. Okay? So all in all, I can group whatever I want in addition and it will still make sense. So let's do the next one. Associative property of multiplication. Much like addition is the same thing. I can group it and group things differently and get the same answer. So if I'm looking here, I want to regroup this, and this time I'm going to use different numbers. I'm going to use 2 times 3 times 4. That will give me 12 times 2 is 24, right? Equals the same thing on the other side, but this time I'm going to group the A and the B. So 2 times 3 times 4. So that's 6 times 4, which is still the same thing as 24. Okay, so that works. That is our associative property of multiplication. Our next one is going to be the distributive property of multiplication. So the distributive property is stuff that we've done in our previous notes. It's always how you guys think. It's what you guys may think of when you do the A times the B times the C, or you want to get your numbers and get rid of the parentheses. You can multiply to get rid of the parentheses. Okay? You guys can't read. So, and you can see A times B is AB and A times C is AC. Let's do that with a couple of equations. Let's say we have 2 and x plus 7. Okay? Well, what's that going to be equal to? I do 2 times x and 2 times 7. So that's 2x plus 14. Okay, and that's an example of what the distributive property does for us. Now, an addition property of equality is our next one. you can add the same thing to both sides and get a new true equation. Okay, so what does that mean? If we have a equals b, then a plus c equals b plus c. That's math mumbo jumbo for basically saying I have two things that are equal. Okay, let's say, for example, that, well, let's just do an equation that might help us. I have 15 minus 4 equals 11. If I add, let's say, add 4 to both sides of my equation, just like it does here with the c, it's going to give me, those gone, 15 equals 11 plus 4 is 15. So it gives me the same thing when I add the same thing to both sides. So the addition property of equality basically says if I add a number to both sides of the equation, the same number, the equation doesn't change. In fact, it's still the same. It's true. Okay? The subtraction property of equality. You can subtract the same thing from both sides and get a new true equation. Just like we did previously with addition. Okay? So let's do that again. This time, let's say we have, let's do 5 plus 2 equals 7, something like that. If I subtract the 2 from the both sides, right, the 2's cancel, and then 5 is equal to 7 minus 2, which is just 5. So it's true. If I subtract a number that's equivalent on both sides, I end up with the same thing. Okay? What about the multiplication property of equality? This can be also identified as the scaling property of equality. You can multiply both sides by the same thing and get a new equivalent equation, but not 0. And I say 0, we say 0, because if I multiply both sides by 0 of an equation, that'll just give me 0 equals 0. Although true, it's not exactly helpful in learning what our value is, or our unknown. Okay? So, let's say we have a equals b here, and you guys often will see it in something that looks more like, let's say y over 5 equals 2. When I think of multiplication property equality, I think of taking care of division. So if I multiply both sides of my equation by 5, the same number, what happens? Well, my 5's cancel, and I end up with y equals 2 times 5, which is just 10. Okay? Now that should work for us, and that will actually give us the true answer. What about our next one? Division property of equality. This is another term that you can use is called scaling, or making your equation smaller to find an answer. Okay, let's say that we have two equations here. You can divide both sides of the same thing and get a new equivalent equation. So what about this one? Let's say we have 4x and we have equals a negative 20. Well, the division property of equality says if I divide one side by 4, I have to divide the other side by 4. If I do that, I should end up with x equals a negative 5, which is an equivalent equation as to my original. Okay. Now, this is our last class that we talked about it, where we talked about the equality property of exponentials. Okay. As long as the bases are equal, then the exponents must also be equal. So, if you guys haven't learned about this, refer to the last section of your notes. It's very helpful in learning what it means. So here in our math section, it says b to the x equals b to the y. So if they both have the same base of b, then x and y must be equal. Here's how I would think about it. Let's say I have 4 to the x equals 4 to the 5. And if that's true, then x must equal 5. Okay? Just like that. Now, let's move on to what we would call the substitution property of equality. Or not property of equality, my apologies. Substitution property. Okay? The substitution property says you can plug something in for something else it is equal to. So here's what I want you guys to understand. Let's say x is equal to 5 times 4. Then x is equal to 20. So the substitution happens right here. 5 times 4 turns into 20. You guys can think of it as actually just doing your basic math. Okay? So, here's an example that I like to use. Let's say we have x minus 4 equals... actually, no. Ignore that one. Let's do x minus y equals 4. And, let's say, b, or y, not b, and then y equals 2. Okay? If that's the case, then it's the same thing as saying x minus 2 equals 4. Okay? All it's saying is if y equals 2, then and x minus y equals 4, then I can write it as x minus 2 equals 4 instead. Okay? All it is substituting things that are the same for each other. So let's look at the next one now. The symmetric property of equality. This is one where you guys normally would want to think about having your variable on the left side of your equations. You can switch the sides of an equation and it's still the same. So, let's say we do all of our work and we get down to a 4 equals x, right? The symmetric property of equality says that we can change that into x equals 4 and it's still the same thing. Okay? Now, let's look at the next one. And it says the multiplicative property of 0. What the multiplicative property of 0 says, if you multiply anything by 0, you get 0. Okay? No ifs, ands, or buts. It's just 0. Anything times 0 equals 0. It could be 4 times 0 equals 0. It could be, I don't know, 112 times 0 equals 0. All of it's the same, right? Do that so it looks a little bit more like the math. Okay? Anything like that is going to be giving you 0, always. Last couple here. Additive identity. If you add 0, you get the same thing. All that basically means is if you add nothing to something, you still have that something and nothing has changed, right? So, let's say I had 4 plus 0. That's still just going to be equal to 4 because I've added nothing to it. Okay? That one's pretty simple to understand. Let's go to the multiplicative identity. If you multiply by 1, you get the same thing. Very much like additive identity, but instead of 0, you want to use 1. So think about it like this. If I have 7, and I multiply by 1, isn't that still just going to be 7? Right? 7 times 1 equals 7. So just like adding 0 doesn't change our number, multiplying by 1 doesn't change our number. What about the additive inverse? So let's say, if you add the opposite of a number, you get 0. So it says here, a plus minus a equals 0. So what does that possibly mean? Well, what if I did this, and we had a negative 2? And what if I added 2 to that? Well, isn't negative 2 and 2, they are opposites of each other. So when I add them together, I'm always going to get 0. Okay? Now, when I have the multiplicative inverse, what we use is called the reciprocal. If you multiply by the reciprocal, you get 1. Okay? Now when I get 1, because of the division here. So, here's what I want you guys to see. Let's say we have 3, and our reciprocal, if you guys can remember, is where we just have a fraction, but it's flipped over. So if I have 3 over 1, then a flipped version of that is going to be 1 over 3. So here, I want to flip this fraction and multiply it by what it's called its reciprocal, or its flipped version, right? And if I do that, you guys can kind of see, and I do 3 times alpha y equals, numerator, denominator, 1 over 3, you can see it equals 1, right? So, if we multiply by the inverse, or the reciprocal, we're always going to get 1, okay? So, that is the video notes for 1.3. If you need any more help, please ask your teacher or email them.